Sometimes data seems to show clear pattern. One group looks higher than other. One method looks better than other. One result looks different than other. But here's the problem. Not every visible difference is meaningful. Some differences happen just by chance. So, before we trust what data appears to say, we need a way to ask very careful question. Is this pattern real? Or could it easily happen by random chance? That's exactly why we need something called p-value. Welcome back to Shital's Data Desk. I'm Shital, and in this video we are going to build clear, intuitive understanding of p-value without heavy formulas and without statistical jargon. In this video, we are going to build an intuitive understanding of p-value. We will begin by grounding ourselves in core idea behind it, starting from assumption that nothing is happening. Using simple courtroom analogy, we will see what question p-value actually answers. We will break down what small and large p-values really mean and why 0.05 threshold is not magic. We will clear up common misconceptions, see how p-values fit into different statistical tests and why they are often misused. Finally, we will talk about when p-values are not enough and end with big picture takeaways. So, we need to start with mindset that statistics always begins with. Statistics starts with skepticism. Before we assume anything interesting is happening, we begin with most boring explanation possible. We assume there is no real effect, no real difference, and no real relationship. This assumption is called null hypothesis. It simply says any difference we see is due to random chance. Why do we do that? Because if we don't assume randomness first, we will end up seeing patterns everywhere, even where none exist. So, key idea is simple. Assume nothing is happening until data strongly disagrees. Now that mindset sets the stage for p-value, so what question does p-value actually answer? This is the most important sentence in entire video. P-value answers this question. If there were truly no effect, how surprising is the data we observed? That's it. Not is my hypothesis true. Not what is the probability my result is correct. Only this. How unlikely would this data be if randomness were the only explanation? If data looks very surprising under randomness, we start doubting null hypothesis. To make this idea intuitive, let's use courtroom analogy. Imagine a courtroom. Defendant is presumed innocent. That's our null hypothesis. Now, court looks at evidence. Key question is not is the defendant innocent. Instead, question is if the defendant were innocent, how likely is it that we would see this much evidence? If evidence would be extremely unlikely under innocence, we reject that assumption. That's exactly how p-value works. P-value measures how compatible data is with randomness. Now, let's see how to interpret small and large p-values. Small p-value means this result would be very unlikely if nothing were happening. So, we say there is evidence against randomness. Large p-value means this result is quite plausible under randomness. So, we say there is not enough evidence to reject null hypothesis. Important point is large p-value does not prove there is no effect. It only means data is consistent with chance. Now you might be wondering, why do we often hear about this mysterious number 0.05? 0.05 threshold is not law of nature. It is a convention. Historically, statisticians needed cutoff to decide when evidence felt strong enough. 0.05 roughly means we are willing to accept 5% chance of being wrong. But here's the key idea. 0.05 is a guideline, not a rule. In medicine, we may demand much stronger evidence. In exploratory research, we may be more flexible. Number matters less than thinking behind it. And this leads us to one of the most misunderstood parts of p-values. P-values does not tell you size of effect, how important result is, whether result matters in real life, probability that your hypothesis is true. P-value only measures evidence against chance. That's why statistical significance and practical importance are not same thing. Now let's place p-values in context. P-values don't exist on their own. They appear inside tests like t-test, ANOVA, chi-square test, regression models. Each test asks different question, but p-value always plays same role. How surprising is the result if null hypotheses were true? So, p-value is not star of the show. It is supporting actor, helping us evaluate evidence, not replace thinking. Unfortunately, this is where many people go wrong. P values are often misused because people treat them like answers. Common mistakes include treating 0.049 as truth and 0.051 as failure, ignoring effect size, ignoring sample size, chasing significance instead of understanding data. Statistics is not about chasing small p values. It is about making disciplined, honest decisions under uncertainty. Which brings us to an important question: when p values are not enough. Sometimes p value alone is not sufficient, especially when effect size matters. Decisions have real consequences. Data is complex. That's why we also look at confidence intervals, effect sizes, practical impact, domain knowledge. P value is a signal, not verdict. At a deeper level, p values teach us something important about thinking. They remind us to assume randomness first, demand evidence before belief, separate evidence from importance. They don't remove judgment, they structure it. So, let's summarize everything we learn in this video. P value measures evidence against chance. It does not measure truth or importance. Small p value means data is surprising under randomness. Large p-value means data is consistent with chance. 0.05 is convention, not a rule. P-values support thinking. They don't replace it. If you found this video helpful, don't forget to like, share and subscribe to Shital's Data Desk. This is Shital from Shital's Data Desk, where we don't fear statistics. We learn how to think with it. Thanks for watching and I'll see you in next video.